Hello, we are proposing to build a roundabout on Woodside Avenue and State Route 67. Our team name is All Around Engineering, and we are based out of SDSU. My name is Corbin Brown. I'm the project manager of the project. We have our CAD and transportation, Kyle, our geotechnical, Nicole, environmental, Alan, stormwater, Casey and Lexi, and construction, Crystal. The purpose of this project is to improve the traffic flow and pedestrian safety at the intersection of State Route 67 and Woodside Avenue by designing and constructing a roundabout. This is our project location. It is in Santee near Interstate 52 and State Route 67. Here are the existing conditions. The intersection is four-way stop controlled. State Route 67 is a four-lane rural highway that has two exiting lanes onto the intersection. Woodside Avenue is a four-lane arterial with 12-foot lanes and 6-foot bike lanes. Here you can see the level of service calculated from the peak hour volumes. Some of the approaches need improvement.
As you can see with the previous slides, the current stop-controlled intersection is not sufficient. We're proposing to install a roundabout. Roundabouts have many benefits, including an increase in safety, an increase in capacity, a reduction in delay and fuel consumption, and a reduction in maintenance costs. Some of the safety benefits include reduced vehicle speeds, an overall reduction in the amount of conflict points as a result of eliminated left turns, and a reduction in the angle of impact in the event of a collision. This results in collisions being generally less severe, with the majority of vehicular collisions being sideswipes as opposed to head-on collisions. Using the volumes from the existing four-way stop-controlled intersection, this table was created to reflect the highest demanding movements. As you can see, the exiting freeway traffic as well as the eastbound Woodside Avenue approach are the approaches that generate the most volume. To bring it all together, this is the proposed design that includes two lanes exiting the freeway, with a combination of a 1 and 2 lane roundabout in order to maintain the 2 lanes exiting the freeway, as well as 2 lanes in both directions on Woodside Avenue. The primary design considerations were geometry, design speed, and sight distance throughout the roundabout. Overall, the proposed level of service for both a 1-lane and a 2-lane roundabout are shown here. The 1-lane roundabout would suffice, but as discussed previously, the 2-lane roundabout would maintain the existing conditions and be capable of operating under future traffic volume projections.
No previous soil testing for the soil under or around the existing intersection was found. However, we were able to find a soil map of the area which revealed the soil type to be Ramona sandy loam. We were able to use the soil type to produce our geotechnical assessment. Due to the project site being an existing at-grade intersection, the amount of earthwork and grading for this project is very minimal. Small-scale clearing of brush and shrubs may also be necessary. Although our earth material manipulation is minor, it can still have adverse effects on the project site and surrounding area. However, we believe that these possible changes will be negligible.
The California Environmental Quality Act, or CEQA, an extension of the National Environmental Policy Act, requires that all proposed projects be subject to a protocol of analysis and public disclosure of environmental impacts. All feasible measures to mitigate those impacts must be adopted, In short, environmental protection is a mandatory part of every California state and local agency's decision-making process. For this project, to fulfill CEQA's mandate, an environmental impact analysis was undertaken and a finding of no significant impacts was concluded. Initial observations of the intersection show a need for better drainage design, better accessibility for bicycle and pedestrian traffic, and intersection clarity and aesthetic improvements. The current design of the intersection is barely adequate to handle current traffic demands and will most certainly not be able to handle the future demands of a growing Santee. A safe crossing from South Woodside Avenue to North Woodside Avenue is required. Completion of and further separation from motorized traffic of existing bicycle lanes is also required. Being the gateway into Santee from the communities of Lakeside, Poway, and Ramona to the north, and aesthetic improvements to what is currently a barely completed as-built environment is required. Improvements to level of service would result in lowering of vehicle emissions. Increased access and safety for pedestrians and bicyclists would result in more people choosing those modes of transportation, resulting in vehicles on the road and less vehicles on the road and less emissions. The improvements to air quality would not be substantial. Visible erosion of hillsides on the southeast corner of the intersection shows that water leaving the intersection is picking up soils from the hillsides. Correcting these issues will result in cleaner water leaving the area. The opposite side of the intersection slopes away from the intersection. Completing the sidewalk between Woodside and North Woodside would result in better runoff control for that area. No significant negative impacts were found to the community, utilities, stormwater runoff, soils, or topography, air quality, noise, or the biological environment. Impacts that require mitigation, mostly during construction, include emergency vehicle access, traffic rerouting, disruption to as-built drainage system, and releasing of built-up deposits in soil during demolition.
To begin analyzing the effects to the project site drainage, watershed basins were delineated in a simplified manner. In Basin 1, there are 2 subbasins, and in Basin 2, there are 4 subbasins. The proposed design did not have a significant effect on the existing basins. This conclusion was determined by performing the rational method, along with the modified rational method, to calculate the peak discharges in each basin. The San Diego County Hydrology Manual and the San Diego County Drainage Design Manual provide the criteria used for the design. Proposed facilities are designed for the 100-year storm event. The modified rational method will be applied at the junction of the project watershed basins. Runoff coefficients are based on soil type and land use, both of which are provided by the San Diego County Hydrology Manual. A runoff coefficient can be determined by multiplying each C value by the percentage of area it includes. The rainfall intensity is determined using the equation provided in Figure 3-1. This was calculated using P6, the adjusted 100-year storm 6-hour rainfall obtained from isopluvials, and D is the duration in minutes, using the time of concentration. The time of concentration can be found by summing the initial time and the time of travel. The initial time can be found in the Hydrology Manual. The travel time is found using the equation shown here, with L being the overland flow length in miles and delta E being the change in elevation in feet.
This summary table reflects the change in discharge on site. The site experiences an overall decrease in drainage due to the addition of pervious land. This decrease of 1.27 cubic feet per second is minimal, but after analyzing the drainage facilities using Flowmaster, it has been determined that they cannot handle the rainfall for a 100-year storm event. This project will include the following upgrades to the current facilities to prevent flooding during such events. Pipe 2 to 4 is an 18-inch corrugated metal pipe with a current capacity of 20.61 cubic feet per second. To upsize it to meet 100-year storm conditions, it will be replaced with a 24-inch reinforced concrete pipe. Pipe 4 to outfall 1 is an 18-inch reinforced concrete pipe with capacity of 14.21 cubic feet per second. To upsize it to meet 100-year storm conditions, it will be replaced with a 30-inch reinforced concrete pipe. Pipe 8 to 9 is an 18 by 24-inch corrugated steel pipe arched with a 36-inch corrugated metal pipe. To upsize it to meet 100-year storm conditions, both sections will be replaced with 30-inch reinforced concrete pipe. Pipe 9 to outfall 2 is a 36-inch corrugated metal pipe. Unless this pipe is in poor condition, it will not be replaced because it is operating within capacity. All existing inlets within the project limits have been determined to meet 100-year storm event criteria. The earthen channel between nodes 6 to 8 has been determined to meet 100-year storm event criteria.
The cost estimate has been broken out into two areas, total capital cost and support. Total capital cost encompasses all of our direct costs, while support incorporates all of the indirect costs related to staffing and design support. The direct costs amount to $2,002,144 and the indirect costs amount to $2,717,772 for a grand total of $4,719,916. The construction schedule has been divided into two phases, pre-construction and construction. The pre-construction phase is comprised of 11 activities with a duration of 251 days. The construction is comprised of 43 activities with a duration of 230 days. The entire project will take 481 working days, which amounts to 96 weeks.
Thank you for your time. We look forward to working with you.